This Week in Parasitism is brought to you by the American Society for Microbiology at microbeworld.org/TWiP. This Week in Parasitism, episode number 40, recorded on May 11th, 2012. Hi, everybody. I'm Vincent Racaniello, and with me is Dixon Despommier.
Hello, Vincent.
You are Dixon, right?
I am. Yes, I am.
Dixon, how have you been?
I've been fine, thank you.
We have the black look again. Is your poison ivy healed?
Well, it's resolving. Let's put it this way. It's taken quite a while, actually.
You told me the other day how it went from your right wrist to your left wrist.
Yeah, how does that work, Vince?
Or via the other way around, right?
No, it went from my left wrist to my right wrist.
And how was that?
Because I was wearing a watch when I caught it on my left wrist, and the oils from the plant actually permeated the wristband on the inside surface. So I couldn't wear my watch on my left wrist. It was bothering
you, right?
Yeah, so I switched it to my right wrist and put a little bit over there too. So I'm an equal opportunity poison ivy giver, I guess.
It just goes to show how the oils last a long time. Yeah, you have some scars, yeah.
Well, it's not. I hope it's not a scar. I hope it's just resolving.
Just resolving. It'll go away.
Induration, as they would call it.
And I understand you've been fishing a lot.
I have.
And you didn't catch any more poison ivy. You learned to stay away from the bushes.
Well, no, you don't do that, but you learn to recognize the plants, of course. But, in the spring when your heart leapeth up, etc., you do foolish things to begin with, and then you regret them sometime later on. At any rate, that didn't upset my fishing. I was fishing right through the...
All right, good.
But this is TWiP, and so we're going
What's on the plate for today?
Well, it's interesting you should ask, because we've got a worm who the medical students, once they heard the name, could never forget it because it was the same name twice. We're going to talk about a filarial parasite, which is in the same group that we've discussed already for the lymphatic parasite. We have Brugia malayi and Wuchereria bancrofti, which we've covered.
Right.
And then we discovered another filarial parasite that lives under the skin as an adult and produces microfilaria that migrate in the skin, and that's called Onchocerca volvulus.
This is a worm. Which kind of worm is it?
It's a nematode worm. It's a round worm. It's not segmented. It's got a gut tract. Come on, Vince. We've done this already.
Oh, I see. The nematodes.
Yes, the nematodes. Or the nematodes, depending on how you're...
We've done Enterobius.
We have.
Trichuris.
Oh, yeah. You going to go down the whole list?
Yeah, sure.
Okay, go ahead.
Strongyloides.
Yep.
Trichinella, of course.
But of course.
The lymphatic filariae.
We did. You skipped hookworm. You skipped hookworm, Vince.
I did?
Yes.
I wonder why.
Because I don't name them there. I just say the hookworms.
The hookworms, yeah. The lymphatic filariae, Onchocerca we did.
Right.
Ah, and now I see.
We're going to do a worm called loaiasis.
Page 156 if you're following along.
Right. If you're keeping score.
Loaiasis.
Right.
I heard, before we move into loaiasis.
Yeah, please.
I should have researched this before I mentioned
No.
But I was listening to Mark Crislip, who is a infectious disease physician in the U.S. who does a podcast. It's called the Puscast.
The Puscast. That's...
He was talking about, he reviewed a clinical trial where they treat people coming from Africa with 1 dose of mebendazole to lower the worm burden so they don't bring it into the U.S.
So they don't bring it into the U.S.
So I was wondering, they found it's very effective. 1 dose, really lowers the burden substantially. So why are they worried about bringing worms? What kind of worms, and why are they worried about it?
Well, that's like bringing coals to Newcastle, as far as I'm concerned, because, we've got worms of our own here that we can match toe-to-toe with anybody throughout the world. But some of these worms that people angst about, let's put it this way, are worms which you could never establish in this country because they require specific vectors.
Mm-hmm.
And, in fact, the one we're going to discuss today, loaiasis, has such a vector associated with it. So the worms that you might be hesitant to bring into the country because we've had it and then we got rid of it, and although we didn't actually get rid of it, strongyloides, that's the one I couldn't think of that the drug would have the most effect against, that would prevent a clinical infection from manifesting itself in an area of high-density population in our country, let's say in a school, for instance. You'd want your kids to be strongyloides-free. I'm not sure one dose of mebendazole will do that, actually.
I need to... Oh, albendazole. Here we go. Albendazole therapy in enteric parasites in the United States-bound refugees. I guess they're going to stay here.
I guess they are.
So in that case, you don't want them to have a parasite burden. Let's look up the reference, Dickson, because here we are in the modern era, and I can type it into PubMed.
We're on the information highway, Vince. You're driving.
Here we go. New England Journal of Medicine, April 2012. Wow.
Okay, that's pretty up to date.
We conducted a cohort study involving 26,000 African and Southeast Asian refugees who were screened by means of microscopic examination of stool specimens for intestinal parasites on resettlement in Minnesota.
Only intestinal parasites.
Yeah.
Note the only intestinal parasites.
And the ones they looked for were intestinal nematodes, schistosomes, giardia, and entamoeba.
That's not a worm.
That's very interesting. It's not a worm. It just says enteric parasites. So
okay.
I misspoke. That was my fault.
Okay.
Among 4,300 untreated refugees, 20.8% had at least one stool nematode, most commonly
Ascaris.
hookworm.
Oh, really?
Yeah.
That's odd.
Among 22,000 albendazole-treated refugees, only 4.7% had one or more nematodes, most commonly trichuris. So it's quite effective.
Right. But
Presumptive albendazole therapy.
You usually need multiple doses to get rid of all of them.
So why do you think they just gave them one, just to simplify things?
To dumb it down, to make it a simple procedure, and to get rid of 90%. Okay,
Yeah.
and they figured by that time you've got subclinical infections of the rest, and it wouldn't matter whether you went to school with that or not. Certainly albendazole doesn't touch Entamoeba histolytica, because that's not a worm anyway, but...
Here we go. Beginning on May 1st, 1999, the CDC recommended presumptive treatment of refugees with one dose of albendazole, 600 milligrams, administered overseas before departure for the U.S. So that brings me again to my original question.
No pun intended, Vince.
Why?
But they wanted to leave their worms behind.
Oh, dear. Are you Alan Dove?
No, certainly not. He has a more resonant voice than I do. But, getting rid of your worms before you immigrate, that's a great idea. But, of course, like you said, 4% of the people given albendazole still harbored another worm, which was trichuris. It's a more intractable infection, harder to get rid of. Perhaps Ascaris would, of course, be susceptible to that single dose. But strongyloides might be another one that you could miss by a single stool examination, because that's not the proper test for strongyloides. You have to really collect a ton of stool in order to make sure it's there. And strongyloides is a very dangerous parasite because, as you know, Vince, it can infect other animals besides humans, particularly dogs and cats.
Right.
And if you put a little kid that's just come from, let's say, Central Africa, if that was a place where this kid was a refugee from, and he's exhibiting diarrhea, maybe intermittent diarrhea, he could contaminate his classmates. The worm has to sit around for about 3 days before it's infectious. So we don't have sanitary conditions like that in this country, do we, Vince?
No.
At least we don't think
We don't think we do.
We used to have them in
the South?
in our mental institutions.
Right, yes, of course. So,
and this was a big problem there. So is this still a good idea or not? Well, it's a good idea to get rid of intestinal worms, but what about the one we're going to discuss?
Let's
try to integrate that into the picture.
I thought that would be interesting, worth a mention.
It is worth a mention.
I heard it in the car this morning, and I said, well, we're TWiPing today, so let me just bring it up.
Right, and so community-based control programs that use a single dose of a single drug, or maybe now we've got a cocktail with 3 different drugs in them. We use ivermectin, we use mebendazole, and there's one other drug that I'm blocking on that I know we were using, and maybe we could look that one up sometime also. It's used as a cocktail to go into communities in endemic centers and try to clean up the population periodically to keep the little kids healthier than they would have been if you didn't do that, so they can stay in school.
Okay.
All right, that's the whole thing behind that. But unfortunately, the overuse of these drugs at that level has resulted in low dose resistance to at least mebendazole and to ivermectin as well. So you have to worry about this, because if they become resistant at a higher level, then you're lost. You don't have a drug.
Sure.
So, at any rate, that's a background to the problem that still exists. That's a recent publication.
Right.
And it says
last month,
these are huge problems in other areas that hasn't gone away just because, A, we don't teach it any longer in our medical schools, or because the citizens of countries without these infections are not aware of them because they don't have them, so they don't hear about them. They only hear about them when they travel.
This is a very special population because they are leaving.
That's true.
And they're going to a specific state, so we can get them and give them this one dose. Right?
That's right.
But wouldn't it be good to treat the entire population?
Well, if you could afford to do that, sure.
We can afford it, I can assure you.
But do we?
We don't do it. I think it's unfortunate. But you'd have to continue because you're not going to eradicate these parasites.
And why is that, Vince? And I totally agree with you. But you said that in a way that you had a twinkle in your eye, because I think you're trying to trigger the response in me.
Because they're in nature, aren't they?
Well, you've got an ecological situation that you haven't solved, and that is fecal contamination of the local environment.
Right.
And as long as you don't solve that problem, you'll always have these parasites.
Well, what if you eradicated them in people? Then they wouldn't be excreting them into the environment.
Only if there are no reservoirs. Correct? So Strongyloides has a reservoir.
Of course, absolutely correct. Yeah.
But East Lytica does not have a reservoir.
Some do and some don't. Okay.
You can get in the list, and most of the intestinal nematodes, there are no reservoirs for it.
I have a solution.
Go ahead.
We just autoclave the earth. And then let
Vince,
afterwards.
You do that, there's no microbes. We need the microbes for other things. Now,
so Mark Crislip, who's the podcaster I was listening to, was talking about getting infections from your pets, which is very common. And he says when that happens, he always recommends that his patients autoclave their pets. He said, which is often met with dismay.
Right.
And I thought, I suppose, at what point in autoclaving would the animal die? Probably soon, right?
Not a nice thought.
Because it's 21 pounds per square inch.
Not a nice thought, Vince.
Yeah, it's not very nice.
No, that's a horrible thing. It sounds like something Torquemada would think of.
Was he a nasty person?
Torquemada was awful. If he had access to an autoclave, he would have used it.
Yeah.
Do you know who Torquemada was? He was the leader of the Spanish Inquisition that kicked out the Moors.
I see.
In fact, Mel Brooks had a great line about him. He says, Torquemada, he says, you can't fight Torquemada. He says, Torquemada, he says, you can't disobey Torquemada. In fact, you can't talk him out of anything. Boom, boom, boom.
All right, that brings us to Loa.
It does. It does.
Where did it get this name?
It's a good question. The name comes from a really interesting parasitologist back in the early 1860s. The guy's name was Kobold, and he was a follower of all of the German parasitologists that spread out from Germany through the world to actually establish the early phases of the field of parasitology, basically. All right?
Hold on. I got to fix something.
Uh-oh. Are we hearing my breathing a little bit too much?
No, I don't hear your breathing. I hear this rattling. But I think it's your dentures. You don't have dentures.
It's probably my brains.
Not the mic. It only happens with you.
Really?
I think it's your jaw.
It might be my glasses that are brushing up against it like this. Maybe I should take my glasses off.
No, then you can't read. Forget
this
it.
Is all, who needs to read? So, Kobold was a...
Cobalt?
Cobbold. Kobold.
Oh, okay.
Kobold. Here, you have the same copy. Kobold.
Oh, I'm so blind.
In 1864, actually gave this worm its name. And the worm that we're going to discuss is it's restricted in its geographic distribution. So what do you think restricts this particular parasite, Vince?
So I can think of several things.
Let's go ahead.
Climate.
That's number one.
Geography.
Number two.
Host.
Reservoir.
Reservoir.
And there is no reservoir.
There is no reservoir?
There's none.
What's vibrating?
No clue. I believe it's your telephone that's vibrating.
It is. I'm going to ignore it, and I will pay later for ignoring it.
Yeah, I'm sure you will.
Maron.
So, climate, geography, host. It only infects humans, so there are no reservoirs. And
Vector.
aha.
Did I get them right? Do I pass?
You did, but the last one is the correct answer.
Vector?
Yes. And
Yeah, the vector. Same with viruses. It can restrict.
of course. And so the vector lives in Central and Western Africa.
It's a good exam question. Provide an example of a parasite limited by A,
Climate,
B, geography, C, reservoir, D, vector.
right.
One of each.
But the vector follows these first two. So
yeah, of course.
they would probably argue that you've mixed your
So
oranges
this
and bananas.
parasite, which is a filarial nematode,
It is.
is vector-borne.
All the filarial nematodes are vector-borne.
I
Every
love
one
these
of them.
blanket statements. I think those are very useful.
I do too.
It helps to integrate.
Categorizes,
Yeah.
and you can pigeonhole these things.
So all the filarial nematodes.
Every one of them.
Wucheria,
Yep.
Bancrofti, Onchocerca,
Black flies.
and Loa Loa.
Ah.
Well, I don't know what the vector is because we haven't gotten to it yet.
Deer flies.
Deer flies. Are
Deer
they so
flies.
called because they feed on deers?
They do.
Deer, not deers.
They do. They do.
And what country are we talking about here?
Well, deer flies are found throughout the world.
We have them here in Pennsylvania.
We sure do. In Pennsylvania, what do you mean here in Pennsylvania? We're not here in Pennsylvania, Vince. We're here in New York City. So, yes,
They
deer.
have them in New York City too.
The chrysops variety of tabanid flies, which this is a vector-transmitted disease of, is found restricted to the central and western parts of Africa.
Central and Western Africa. Okay.
Yes. This particular version of the deer fly.
All right, and that is what restricts this disease to
That's correct.
parts of
This
Africa.
is absolutely correct. So if you wanted to know whether the climate is changing or not, and if you knew something about the behavior of chrysops, you could tailor your studies
Right.
to the distribution of Loa Loa, and you would find out about the tabanid flies. Okay?
Nice.
And then we have other things transmitted by flies, too. Remember, we talked about trypanosomiasis.
Mm-hmm.
That's the tsetse fly. All right?
You have a picture of a deer fly in here?
I have a picture of
No.
a deer fly. No, I don't. So if you go to
We could find it.
your local
So
resource,
What's the particular
chrysops, CHRYSOPS,
Mariana or just chrysops?
just chrysops.
The deer fly. Oh, they have plenty of pictures.
Tons.
This one with the,
Yeah, there's
the
just
eyes.
there's tons.
Beautiful, isn't it?
Oh, they're gorgeous flies. Deer flies are beautiful flies. They have beautiful wing patterns, and they're not so beautiful when they bite you, however.
Did you know they're known as yellow flies or stouts?
Also known as mango flies, I believe. In here, I believe.
Pests. They can be pests to cattle, horses, and human. A distinguishing characteristic is a patterned gold or green eye.
Mm.
What's the?
No, I just went.
Did you know that? They are actually called the greater family are horseflies.
See?
I didn't know that.
Okay, you have deer flies and horse flies.
Smaller than wasps.
Yep,
Female deer flies feed on blood.
they do.
Whereas males collect pollen. They're the farmers. They're green.
They're like hippies.
What have you been doing today? Oh, I got some pollen.
That's right.
Can't you do anything better with your tongue?
No, I got some achoo pollen.
We're being silly.
We are.
We're not supposed to do this.
We can be a little bit silly.
It says here they are potential vectors of tularemia, anthrax, and Loa Loa. Hey, that's where we are today, Loa Loa.
That's exactly right.
Where did the name come from? You didn't answer yet.
I did, from this parasitologist named Kobold.
How did Loa
Now,
Loa
what
come
does Loa Loa actually mean?
That's actually the genus and species, right?
That is correct.
So it's L period Loa,
This is right.
but it's not named after this gentleman, Kobold.
No,
right?
Kobold named it.
Oh, okay. So what was his inspiration?
I have no idea.
Can we ask him?
You can't go online and find out this information. It's too bad, but you can't do
How
it.
do you know?
Well, I bet you can't.
Dickson, do not underestimate the power of
I've been
internet.
surfing the internet for the last 2 days on this subject, and I haven't run across any reference to how it actually got its name.
All right.
Sorry to say that, but I haven't.
You just haven't looked hard enough.
Maybe. But there used to be a wonderful set of books in tropical medicine, the history of tropical medicine. And it was a 2-volume set published by Kenneth Mott and Benjamin Keene. Benjamin Keene was the parasitologist at Cornell's medical school for many, many years and very famous. And these two gentlemen decided to get together to publish the original papers for every single major parasitic infection.
The original discovery paper, you
The
mean?
discovery paper, and some of them dealt with their biology as well. And I unfortunately loaned both volumes to a student.
Never saw them again.
They disappeared and never came back. And I tried to buy this online, and I just can't find it.
That's too bad. That would be a neat collection.
Well, I thought I had a neat collection, and I've lost it.
All right, so Loa remains obscure how the name arose.
Correct. It might have been a location in Africa. Okay, a lot of this turns out to be location specific.
Let me type in Loa. Just Loa.
Right.
If we do Loa.
Exactly. It could have been a place in West Africa.
Loa are the spirits of Haitian voodoo.
Well,
No,
Hades,
that doesn't account.
Haitian people come from the West African part of the world, because that's the French-speaking part.
It's a bar in New Orleans, too. The Loa Bar.
Nice.
I wonder if it's infectious.
How about Africa, geographic region,
Mauna Loa
Loa.
volcano. The Mauna Loa volcano is
That's
Hawaiian.
different. That's different.
Yeah, but the Loa must mean something.
I'm sure it does. I am absolutely positive that it means something, because none of these have its origin.
Okay, Mauna Loa means long mountain in Hawaiian.
Maybe Loa means mountain, but that, you know what? Those names came from the Hawaiians. I don't think they knew the people living in West Africa.
It also means local office on aging, which you might be interested in. I'm such a bad guy.
We're not going to waste the listeners' time, surfing the internet and not getting anywhere. Let's get on with this subject first.
Loa, Filarial Nematode.
Correct.
Filarial meaning?
Well, it's part of a group of live-bearing organisms that are nematodes.
Mm-hmm.
Right, but not all live bearers are filarial parasites. Okay, for instance, Racaniello is a good example of a non-filarial live-bearing parasite. But most, in fact, I think all of the filarial parasites, at least, because they're vector-borne, Vince, and they have to get their offspring to the vector, produce not eggs, they produce live larvae. So this parasite has a very unusual biology. But I must also regress back into the history of this for a moment to reveal the fact that the complete description of this parasite, male and female worms, were derived by Sir Argyll Robertson. Sir Argyll Robertson. Sir Argyll Robertson. He lived in England and had, you would call these domestic workers. All right, they're not slaves. They were not slaves. They were hired help from various parts of the world, and one of his hired domestic workers happened to be from a place in Africa called Old Calabar. Now, Old Calabar, it's difficult to look up where Old Calabar is because it's now called something else, but it's on the west coast of Africa. And this woman had parasites which migrated across her eye. Now, how can a parasite migrate across your eye and not cause blindness? Remember, Onchocerca's larvae migrated into your eye, and you became blind eventually, and it was called river blindness, right?
Correct.
This parasite lives as an adult under the skin and migrates. The adult worm migrates under the skin now.
Where? Any part of your skin?
All over your body.
And it goes to the eye.
It can, but it doesn't always.
What's the trigger?
There's no trigger. It's just random movement of this worm. And wherever it goes, it leaves behind a trail of metabolic products,
Okay.
which eventually the host becomes hypersensitive to and begins to react to. So if you want to know where the worm is, you find a swollen area of the body and look ahead of that, because the worm is somewhere ahead of it.
So it sounds like it's existing just below the skin, or
it's in the subcutaneous tissues.
All right.
That is
It's
correct.
not within any vessels or anything.
No,
It's
not at
just
all.
Free.
It's not free, but it's trapped between two layers of tissue, the dermis and the sub. Well, let's try it again. It's between the fatty layer that separates the subcutaneous tissue from the muscle
All right.
and the epithelium, which is on top. So this worm lives in this soft, mushy zone
Right.
that we call the subcutaneous zone.
So, and they can move around.
Quite freely,
How big are
apparently.
these worms?
These worms are
Centimeter?
very long. I mean, I will tell you exactly how long this worm is, because Sir Robert Argyle, no, Sir
Argyle Robertson.
Argyle Robertson, I'm sorry.
Did he invent the socks, Argyle?
Well, I believe that Argyle was a family pattern that they did translate into socks. So the adult worm is, it varies, okay? And what I was going to tell you was that this woman from Old Calabar had swellings on her body, which characterized where the worms were. He didn't know that, of course, but he eventually saw these worms in her eyes and actually surgically removed each worm.
Wow. So are they embedded in beneath the outer
They're in the
layers of
subcutaneous tissue. As you'll notice
Of
in
the
your
eye.
life cycle drawing in the bottom right-hand corner, we've depicted a version of this
eye?
infection.
Yeah, so it's not on the surface of the eye. It's under.
Correct, but it doesn't migrate across the pupil.
It stays in the white part.
Sclera. It
Yeah.
stays in the sclera. So if you go to the internet, under images,
I saw a bunch of them.
and type out loaiasis, you'll see
Yeah,
lots
lots
of
of
eye pictures.
Yours
tons
is
of
nice because it's drawn.
it's
I noticed alongside your eye is an arm with a swelling on it. It's called a Calabar swelling.
correct. Named after the town where
where the woman was from.
where Argyle Robertson's domestic worker originated from.
So she had the swelling on her arm.
She did.
And it's got worms in it, I presume.
Not in it. The swelling is from the immune reaction to the worm metabolic products.
Okay.
So to know where the worm is, you'd have to look ahead, on either side of this swelling to find out where the worm has been. The swelling is where the worm has been. It's not where the worm
Now the
is.
worm is no longer there because
It's
it's,
no
left
longer
behind
there.
this trail of,
Right, exactly.
of
So we're trying to catch
antigens.
up to it, but we can never quite catch up to it.
So how many worms does a typical person have?
That's a very good question, Vince. Very few, usually. Very few.
All right.
This woman happened to have two, and when he extracted them, it turned out one was a male and one was a female.
But doesn't have to be that's the case.
No, you could have been unlucky and just extracted two, and they were both females, for instance. If they're both females, of course, they're not going to give birth to live larvae.
But if they're a male and a female in a single person, they could mate and
It's exactly what happens.
give rise to more worms.
Usually there are males and females present in both in the infection. Usually, because this is an interesting way of transmitting this infection, right?
So this is originally transmitted by a deer fly.
That takes a
Specific.
blood meal, only females, and
Takes a
sucks
blood meal
up
from whom?
from a person with two adult worms, one male, one female at least, and
All right.
perhaps
It's
they
not
have more than
It's
that.
not picking up the adult worms.
Oh, Lord, no. It's too big. I was going to tell you how big it is. It's 0.5 millimeters wide and 60 millimeters long. That's the female. And the male is 0.4 millimeters wide and 32 millimeters long. So these are big worms. These are worms that you can actually see with your naked eye.
Sure.
And
And it's in your eye, too.
well, you're laughing, but I can later on. I'll tell you about an incident that happened right here at Columbia Presbyterian
Oh, yeah?
Hospital. Yeah, in the emergency room. So you don't even know you have these things. They're benign. Okay, they're benign. Believe me.
But you have lumps on your body somewhere.
You do, but some people have lumps on their
It
body
doesn't-
anyway.
It does not kill you.
It doesn't kill you. No.
Does it make you blind?
Of course not.
I thought you have an immunological reaction to some product it's secreting, so that doesn't
You
happen
do.
in the eye, right?
Correct.
Because the eye is an immunoprivileged site.
Oh, Vince, you're way ahead of the curve here.
No.
You're absolutely right. That's true. So that when the worm migrates across your eye, you know how most of these are diagnosed, at least in different parts of the world, when these people migrate from that part of Africa, let's say, to let's say Europe or the United States or South Africa or South America. The men will often see this worm in the mirror as they're shaving.
In their eye.
In their eye, and they go, "My God, there's
my
a worm
gosh.
in my eye. I better go to the emergency room and have it
That's
removed."
our title. There's a worm in my eye.
There's a worm, doctor. There's a worm in my eye.
That's good.
That's right.
So then they go seek medical help.
They do,
And by the time they get there, the worm has gone out of the eye.
That's could happen very frequently.
So they don't stay in your eye forever.
They
go
do
somewhere
not.
Else.
They're not quite that fast, though, Vince.
This is a good anatomical dilemma. How would it get in and out of the eye? It's below. Does it go through the back?
No. You have to realize that the eye is contiguous with the subcutaneous tissue.
Yeah, okay.
And we know this from Onchocerca volvulus, because the larvae migrate throughout the subcutaneous tissues, not the adults. The adults stay put, but the larvae migrate, okay?
Yeah.
And we know that they get into the eye. So there must be an anatomic connection between the subcutaneous tissues and the eye itself, and there is. Otherwise,
it's easy to migrate. Okay, yeah. Otherwise, if you think of the eyeball as a self-contained ball, it's wrong.
It is wrong.
It's hard to traverse.
If it wasn't connected to the back of your head, you wouldn't be able to see.
Yeah.
All right,
but we didn't. So the flies bite an infected host
and deposit larvae on the skin, just like black
Where did the flies get it from another person
of
who
course.
had? And these people
there are no reservoirs.
What's the name of the form that's in the blood that's picked up by the
microfilariae?
Oh, it's just like many of the other.
All of them.
Microfilaria. They're very small, so the fly can pick it up. So your blood must have a lot of microfilaria in it.
Or these flies suck a lot of blood.
It's a little fly. Now
it's not so little though, Vince. A horse fly? Come on, these are deer flies. They're pretty big.
Now let me ask you: are microfilaria present continuously or only after mating?
Well, they can't be produced unless the female has mated.
So the female mates. Now, where do the eggs develop in her?
Yes,
and then they're fertilized within her. So
that's correct.
And
it's interesting. It's interesting you should ask about the life cycle here because very little is known about this. Because how do you do the studies? There's no reservoir hosts.
Only people.
Only people. So you have to derive everything.
Animals have nothing resembling this?
They do not. They do not.
Is the genome sequenced?
I doubt it. This is one of those minor
medical
infections.
Importance.
Yeah, because it doesn't cause much clinical infection.
Yeah. How many people are infected? We have no idea.
Probably. No, about 13 million. We know how many people might be infected with this because it's an easy diagnosis.
What's the diagnosis?
You just take some blood and you do a KNOTT test.
What does that stand for?
The man's name.
And what's a knot test?
A knot test is a way of concentrating the microfilariae out of a lot of blood.
Mm-hmm.
And you lake the blood basically open and make it hypotonic. And you lyse all the red cells, rather.
Wait, are these microfilaria within the red cells?
No, they're not, but they're confusing. If you had all those red cells to look through and the blood, so you can get rid of the blood, basically, without having to get rid of the blood, if you know what I mean.
Okay.
Then you can centrifuge it down and look in the pellet, and it's more complicated than that, but that's what it does.
So when you get bitten by a deer fly that's carrying microfilaria, you could get one.
No,
or
they're
two.
not carrying microfilaria.
They're not?
They're carrying the third stage.
So they start
parasite.
to mature in the fly.
They do. They go to the flight wing muscles first, just like they do in black flies.
Okay.
They go through some changes, and then they migrate out after they've molted and gone to the third larval stage, which all nematodes molt 4 times, right? And then they make their way into the mouth parts and the hypostyle. The cutting plates of these flies are vicious. All right, I'm putting my hands together now, Vince, in front of you to show you how these flies actually feed. It's not like a mosquito that it probes around for a little pore in your skin and then injects an anesthetic and an anticoagulant and all kinds of other. These flies are vicious. They just burrow in. They use these mouth parts like scissors, and they slice up a piece of tissue. Blood accumulates in the space, and they suck up the blood and fly off. And you realize, of course, and you know you've been bitten.
Yeah, by a fly. Yeah,
by a black fly, by a horse fly or a deer fly. I mean, it's painful. So very few of these flies are getting away with this. By the way, there's a lot of dead flies in the bottom of a boat. If you're out fishing or just out canoeing or something like this on a river, and in the United States, the deer flies are all over the place. They breed in water. They are aquatic insects.
Okay.
All right. In fact, if I'm not mistaken on this, I think all of the filarial parasite vectors are aquatic insects. Black flies breed in water. The mosquitoes breed in water. And the chrysops breed in water. You should see what the larva of the chrysops looks like. It's huge. It's about 2 or 3 inches long.
Wow.
But it
shrinks
down, right?
So you get a few of these third stage,
right, deposited
larvae
on the skin as it's slicing its way through your tissue,
Uh-huh.
and then as it withdraws its mouth parts, the larvae crawl in.
The larvae crawl into the wound.
They do.
Wow, that's interesting.
It's kind of cool, right?
Well, they're not delivered by. And how do they get out of the fly again?
They sense the heat of your body.
Oh, okay. This
And-
happened before in another case. Yeah,
Well, all the filaria are basically
that's
the
right.
same.
Yeah, and then they crawl into the wound.
They crawl in,
and they
after
probably
you-
don't go far because they're like the subcutaneous area.
Well, the subcutaneous area is your entire skin, so they can go anywhere they
And then they
want.
mature into adult worms.
They do. They molt another time, and
So
then
you
they
could
grow
get-
up.
They grow up.
Then they mate.
So you could get 1 or 2 or more, right? Depends on the dose.
If you had one worm, you wouldn't worry about it, because then you
Well,
couldn't.
you'd get a worm in your eye, but it wouldn't mate and
Correct.
it wouldn't make more.
You would not be a host that could disseminate this infection.
So if you have 2 or more and 2 different sexes, then
That's right.
they will mate. So the question is, Dickson,
it's-
how do they find each other?
Well, I already went into this. Delightful.
You did?
The answer is we don't know, but it's apparent that the males and females are producing chemicals which are attractive.
Okay,
So
because
we'd
the
call
body is a big place to be
We
wandering.
call them pheromones. Yeah, but they're all right at the bite side first.
They don't go far?
Not before they mate. I don't think
Is
they
that
would.
right?
I
Okay.
think they stick around for a while.
So then after they mate, they say, I've had it with you,
Exactly.
and they go their own ways.
Exactly. Well, the males probably die
Oh, of course.
after mating,
They've served the utility.
just like the rest of the male population of the world. We're only good for one thing. We mate and then we pass out,
I see.
basically.
So
I used to
you
say.
think the males die and then the females left to just live out her existence in this person?
Apparently not, though, because otherwise Argyle Robertson would not have been able to discover both male and female worms.
Yeah, in the same person.
That's right.
So, well, maybe they had just mated and the guy wasn't dead yet, the worm. He was lucky, in other words.
May have been lucky. But I think the males actually stick around for a while here. It says here, the larvae in the subcutaneous tissues of the host develop slowly into adults. It takes 1 to 4 years for this to occur. That's a long
It's a long
time.
time, yeah.
But wait a minute. Here's another long-lived parasite, Vince. How in the world does this parasite manage to avoid our immune system during that time?
Well, it has to
How
suppress it.
can
It
it
has
do
to.
it?
It has immunosuppressants.
It must,
It would be interesting to sequence the genome and discover them.
wouldn't it?
I mean, most of these parasites have these sorts of immunosuppressive
This would be a
agents,
fabulous candidate for that. I mean, you say there's no medical importance to loaiasis because it doesn't cause much disease. Yeah, but it might have a secret or two that it's going to give up if we start looking at its biology a
right?
little
Of course,
closer.
there's always a secret.
So that's amazing. Look at this. And the other thing is that the adult worms can live up to 17
years.
years. That's an incredible time.
So you have to think that some of these, at least once a year, so these people have to see a worm crawling across their eye and they don't do anything about it.
Well, they obviously don't feel it either, because if they did, they would be driven to madness, I would presume. They don't feel this either. So this worm must be secreting anesthetics and immunosuppressives and maybe anticoagulants. Who knows what else, right? Its pharmacopoeia must be big. This is a great worm to take apart. You asked me if the genome had been sequenced.
Yeah, I'm just looking it up, but they have the mitochondrial genome. But
That's different. You know why they did that, Vince?
why?
Because they were looking for something else.
They wanted to see where it was from?
No, they were looking for something else. What do you think they were looking for?
Targets for inhibitors?
No, you run another podcast called TWiP.
TWIM.
No, TWIM. All right,
They
TWIM.
wanted to see what bacteria gave rise to these guys?
Yeah, because what if they had found another kind of bacteria? Can we think of another bacteria that might be living inside of a filarial worm, Vince?
Wolbachia.
Bingo. You get A+.
Wolbachia.
So they looked for it in this one.
I didn't find it.
Nope. Did not
Okay.
find it. They also did a genomic blast search for it and didn't find it that way either.
Cool.
So this is not, that maybe explains why it's not very pathogenic.
So basically no one dies of this disease, right?
No one has ever died
Now, if
unless
you
the
were-
surgeon botches the job of removing the worm.
If you were immunosuppressed, would it be a problem? So if you have AIDS, would this be an issue?
Never.
No.
No, this doesn't cause any.
Because it's just a couple of worms in you and they're just...
We
antigenic trails and causing
don't know how many
immunological
worms.
reactions. In fact, if you were immunosuppressed, you wouldn't have any of these bumps probably. So you
Maybe
wouldn't know
not.
about it.
Maybe not.
But I would not like to have a worm crawling across my eye.
That would be disconcerting.
Have you ever seen a case of loa?
Well, I'm going to tell you about this. I haven't actually seen this case, but I can tell you what happened. One day, I was sitting in my office minding my own business.
How many years ago was this?
This was about maybe 15 or 20 years ago.
You were a young man.
I was a young man. And I was known then, and I am still today, as the resource for parasitic diseases at Columbia Presbyterian Hospital. And I treasured that position, and that's why I tried to stay abreast and still do try to stay abreast of the situation, because every now and then I still get a call from a clinician wanting to know something about an unusual parasite that showed up on his doorstep, or hers. So I get this telephone call from the emergency room. And they said, and it was one of my former medical students, so they knew who to call. So they said, Dr. Despommier, there's a man down here who claims that he has a worm in his eye. What should we do? And I said, remove it.
The eye or the worm?
I said, where's he from? They said, he's from Ghana. I said, oh, how big is the worm? He says, he claims it's in his eye. Can that be true? Now, the reason why they were asking me, and they were former students of mine, why would they be asking me for they should have heard that in class.
Did you teach it in class?
Of course not.
Yes.
We didn't
It was minor medical importance.
It was minor. We had to triage the parasites into the groups that we would see a lot of, and the ones. But here it was on our doorstep.
Right.
A Ghanaian transfer student. Right.
Now, would you expect it in Ghana?
Of course.
Yes.
Oh, absolutely. Okay. That's one of the big places for it. And we have a lot of people from Ghana that travel, and true for Nigeria as well. So you see it all throughout West Africa and Central Africa as well. And lo and behold, they removed his worm. I think they might have referred him over to the Eye Institute.
Yeah, they should do that in the Eye Institute.
And the way you do it is it's quite clever. You make a little, you numb the area, of course, and you try to get the patient
to numb it.
Well, you put some Novocaine drops or something else.
Drops, okay.
I really don't know the exact anesthetic that they're using, but it completely makes the eye insensitive to touch. You'd have to do that, right? Because you don't like people poking in your eye.
Yeah, of course.
And then they leave the eyelid open, much the same as, remember Clockwork Orange?
Yeah, right.
The little clamps that they use to keep your eyes open and they irrigate your eye. And then, of course, then you have to remove the worm. So how do you do that?
Make a little incision.
A tiny incision on both sides of the worm so it has nowhere to go.
Oh, and you let it crawl out?
And it will actually poke its head out.
Uh-huh.
And you can grab it.
Pull it out.
And then slow.
You don't want to break it, though.
What happens if you break it, Vince?
Well, then it's dead and it can't move. And you got to get the rest out because you probably have a bad reaction.
You'd have a bad reaction to that. And do you know another worm where that's also the case?
The ones, filarial worms in your leg, right? Wucheria? Dracunculus? Is that the one that where you put your foot in the fresh water and it bursts the boil?
That's the one.
So if you pull, so that's why they wrap the pencil around it and pull it out slowly.
That's right. So this is a little bit similar to that in the way you remove it, but it doesn't take that long.
Just be careful, huh? Interesting.
Be careful. Be careful. Yeah. So how do you be careful? Well, you have to be careful. So this parasite has an unusual lifespan. I mean,
the length is unusual?
Very, very unusual. I mean, I'm in the process of writing a sort of a parasite memoir of my
parasite memoir. It's good.
My early days, and
you could call it Memoirs of My Parasites.
The parasites I have known.
Well, that could be about people, right?
That's right. So you know the name of this book, right? It's called Parasites, People, and Plowshares. The plowshares part is how you turn their swords into our plowshares. And I have neglected to put loa into that category, but I'm going to do that now because of this podcast. And it reminds me of the fact that there are other long-lived parasites out there that need to be heralded and championed by someone who now sees their usefulness, even though the clinicians don't have much use for it. The research scientists certainly might find a good use for this one.
So they say they have a PCR assay to detect the microfilarial genomes in your blood.
Sure.
So if you have microfilaria in your blood, would you be treated with some drug? Would albendazole do anything to these guys?
You know, it claims that diethylcarbamazine is listed here as one of the major drugs, which is a very, very powerful drug. And it ends up killing both the microfilaria and the adults. Now, when you kill an adult worm, then it's in your subcutaneous tissue. It stops immune inhibiting. You're likely to exacerbate a powerful immune response.
Just like the other filaria.
So you might want to temper this with some steroids as well, so that when you give the dose of diethylcarbamazine, you might want to also give some steroids to keep down that reaction that's going to result afterwards. And so it says here, antihistamines or corticosteroids may be required to decrease the allergic reactions during the treatments. In up to 50% of the patients, DEC or diethylcarbamazine treatment may need to be repeated several times in order to effect a cure. Adult worms in the eye must be removed surgically.
Yeah.
Weekly prophylaxis with DEC given in a dose of 300 milligrams is effective in preventing loaiasis among long-term visitors, like Peace Corps workers.
Loaiasis. I like the name.
It has a wonderful lilt.
So this is of minor medical importance, but it is interesting to talk about. Is it a unique lifestyle?
Very.
The pathogenesis is interesting, and it lives a long time.
Right.
One more thing. If I traveled to areas where this infection were endemic, this parasite, would I be at risk for being bitten by a fly and acquiring this?
Of course you would.
So I could bring it back.
What if you went on safari, for instance?
Sure.
Oh, could you bring it back? Of course.
Well, yeah, you would, because it takes a few years for these worms to grow up.
1 to 4 years after you get bitten, before you even know you have it.
So if I one day saw a worm in my eye and I went to a physician, if that physician were up on it, he or she would ask for my medical history, not just the past year, but the past decade probably. Have you been to, so he or she would see a worm and should know immediately this is loa if it's in my eye. It's not, no other worm is going to do that, right?
That's correct.
Have you been to parts of Africa in the last 10 years? That's what I would say.
Sure. So Harold Brown, who used to teach this course, had a wonderful expression for this. It was a quote from a Shakespearean play called Julius Caesar. And the quote is Unde Venis.
Unde Venis.
UNDEVENIS.
Right.
And it means, where have you been?
It's good. I like that.
Unde Venis.
Yeah, also Harold New was good at that.
He was excellent.
He was head of infectious diseases here.
I knew him very well.
Was very good at figuring out what you had, because he'd ask your history. He said, find out where they've been.
Correct.
And it will tell you a lot.
Correct. No, Harold New used to consult a lot with Harold Brown. They had mutual respect for each other. And in fact, after Harold Brown left, Harold New and I became good friends.
Where did Harold Brown go?
He went to several places, actually. He went to the University of Kentucky to teach this medical school course in a short form. He also went to the University of Puerto Rico in San Juan, which he helped establish, by the way, as a medical school, and taught there for a while, too. So he used to go around the world and teach these mini courses in parasitic diseases. He was my mentor and my hero. He was a big...
We have discussed him previously.
Yep. And,
on TWiP.
The memory has not left. So it's essentially, according to some philosophers, then he is not dead.
I meant to mention in your book, Plowshares and Parasites, whatever it's called.
Right. PP and P.
Put a reference to TWiP in it.
I've already done that.
Is it in it?
It's already
You
there.
should say, if you want to learn more about parasites, go to microbeworld.org/TWiP.
It's already in the book.
Very good. It was nice. I enjoyed that.
Yep.
Would you like to hear a few emails?
Who could say no?
First one is from David, who writes, "Love the TWiPs."
You didn't... Wait a minute. We haven't finished with the loaiasis.
Okay. Sorry.
So, no, because
But
we
you
haven't...
said it was okay to do emails. So.
I did. But
you can go
you
back,
were
rewind.
premature email.
Pardon me. Go ahead.
We need to talk about prevention.
Stay out of the areas that are infested. If you're living there,
but there are no reservoir hosts, Vince.
Prevention.
Smallpox we got rid of it because there's no reservoirs. Polio, almost got rid of it because there are no reservoirs. So there's a real chance for eliminating this altogether.
Yes.
How?
Filter the water through Saris.
No, that's dracunculus.
Kidding. Can we get rid of the vector?
No way.
No way.
Absolutely no. Because the vector will bite other things besides humans and get their blood from other people. From other things, rather.
But this worm does not survive in other animals. As far
Correct.
As you know. But
As far as we know.
It may be out there and we don't know about it.
So if you gave a preventative, right? Let's make our imaginations run wild here. I didn't see the word ivermectin mentioned, but if ivermectin had been mentioned, then that would have been a good candidate for prevention. They mentioned diethylcarbamazine as a preventative. That's, diethylcarbamazine is a pretty powerful drug. So I wouldn't say that you could treat an entire region of Africa with DEC to get rid of loa, because loa isn't that big of a medical problem. But prevention and control is very important. I mean, it would be a very, very good candidate for being able to wipe it out.
Yes, but it would require resources that would have to be diverted from something else.
You're quite right.
In areas where
this
is present, what else is a bigger problem? Malaria?
Oh my God, yes, and AIDS.
Tuberculosis, AIDS.
Sure.
They need to be taken care of.
Of course, and hookworm and strongyloides and ascaris and all those other problems. So, but some of them would respond very well to this drug, by the way.
Is this a candidate for a celebrity to take on and eradicate?
No, but it is another candidate for a parasite whose biology indicates that it would be possible to eradicate it due to the fact that it doesn't have...
Yeah, you'd have to use drugs. Yeah.
So, this would be a good question to pose on a board examination, for instance, or to students of infectious diseases in general. Say, make a big list of infectious agents that are susceptible to eradication programs because there are no reservoir hosts.
Right.
It forces you to think about the biology. So I think that's a good think piece. Okay, now we can do the email. Now I'm happy.
All right. David writes, love the TWiPs. I'm a Helminth user, 25 hookworm for allergies.
Right.
So your programs are fascinating.
Huh.
So you can take hookworms to control allergies.
You can.
It's accepted. Where do you get the hookworms? Where do you buy them?
You need a special purveyor of worms.
Dr. Racaniello, after listening to TWiP 33, where you were discussing the history of your surname, I thought I'd give your listeners a way to remember your obviously Italian name. It's the rap song Black and Yellow. Have you heard of this?
No, I have not.
He gave us a YouTube link. So it's a rap song. Came out last year. It's called Black and Yellow. And there's a part where they sing Black and Yellow, Black and Yellow. It sounds like me. In fact, last year in my virology class, once the students came up and said, Dr. Professor, did you know there's a rap song that has your name in it?
Close.
So I went and told my kids, and they say, yeah, everybody at school tells us that all the time.
Right.
Peter writes, Dear professors, please do not abandon your style ever. Even if there's some privacy in there,
we couldn't.
Be it fishing or simply the weather or whatever, it has to be in your podcasts because it makes them authentic. Even more, talking like you with so much commitment and humor increases the amount of learning. You know why. I always tried to be a good teacher for natural sciences at a German secondary school since more than 20 years exactly in that way. And scientific researches in recent years have proved that the brain of all ages learns better and more effectively with these attributes. He gives a link to something. Let's see. Stanford imaging study shows how humor activates kids' brain regions.
Neat.
So humor is important for teaching.
Right.
And remember, just because information causes an emotional response, and that means attention is rising. So let's see here what he has sent us here. The adolescent brain learning strategies and teaching tips. Mm-hmm. All right.
Adult humor works that way too, by the way.
Please keep on with your excellent work. You are pioneers in science and face-to-face interaction. Greeting from Wiesbaden, Germany. Peter. Peter sends a link to his webpage. Is that right here? Let's see. No, it's a link to Wiesbaden in Germany.
Nice.
Thank you. Thank you, Peter. We won't change, will we? We're too old to change.
How could we?
Richard writes, Dear Dickson and Vincent, I recently delivered a lecture to nursing students at Kilimanjaro Christian Medical Center in Tanzania.
I'm familiar with that place.
On a subject that Dickson is very well versed, trichinella.
Cool.
I'm a medical entomologist and have no knowledge of trichinella, so quickly had to do some reading and piece together a basic lecture. In the process of preparing the lecture, I was left with a couple of questions that I hope Dickson can answer. Oh, of course.
Try me.
To the right
Try
place.
me.
In East Africa, the species is Trichinella nelsoni.
Correct.
My understanding is that there have been very few human cases reported, 200-ish, and they have all come from eating undercooked warthog or bush pig.
Correct.
In Tanzania, pork meat from domestic pigs is commonly eaten. On a side note, pork is called kitimoto in Swahili, which translates to hot chair, possibly because if the Muslim population of Tanzania get caught secretly eating pork, they will be in big trouble, or the hot chair. I was left wondering why T. nelsoni has not made the jump from wild pigs and warthogs into domestic pigs. I was asked this question in class, and my explanation was that it could be due to geographic isolation, as warthog wild pigs are mainly found in bush and savanna areas where usually only Maasai are found. Maasai keep cattle, sheep, and goats, but not pigs.
Correct.
Do you think this is a reasonable explanation? How would you have answered this question? With rapid population growth in Tanzania, do you think expanding human settlements could result in T. nelsoni making the jump into domestic pigs and resulting in more human cases?
Well, that's a fascinating and complicated question because it requires knowing something of the local ecology of where the pigs are being raised. And let's start with domestic pigs in the United States, for instance. The common species there is Trichinella spiralis. Okay, it acquires Trichinella spiralis by two mechanisms. Both involve eating meat, of course. Can't be transmitted without eating raw or undercooked meat. So where do the domestic pigs in the United States get raw or undercooked meat from? The one answer is from infected rodents, which live peridomestically with the pigs on these farms and acquire the infection from parts of pigs that are slaughtered on the farm before the pig carcasses are sent off to market. There are very few of those operations left. So the fact that pigs are slaughtered now in slaughterhouses under controlled conditions have limited the amount of trichinosis in this country. The second source of trichinosis in this country came from pork scraps, which were collected at meat packing plants and sold back to the pig farmers as food for the pigs. Without cooking or steaming it, you could still transmit a barnyard infection back to the same place that the meat came from, basically. Okay, so now I'm going to ask this gentleman whether or not he knows of the practices of domestic pig raising in Tanzania. By the way, it's called Tanzania, not Tanzania. That's okay. It's a matter of choice. I would prefer to go to Tanzania rather than Tanzania. So, because Tanzania sounds like something that Denny Kaye would sing.
I have made that error previously on TWiP.
Not a problem.
That I don't learn.
It's not a problem.
Tanzania. It's Italian.
It is Italian. No, there's no question about it. So it used to be called Tanganyika, by the way, and it was thought to be owned, in quotes, by the Germans. Ha ha ha. No part of Africa was ever owned by anybody, right? Okay, so how domestic pigs are grown up, raised in East Africa matters a great deal. And I don't think there are any pork scraps left. All right, everything is eaten. So there's no chance of the pig actually forming a cycle here. And the bush pigs are geographically separated. All right, and they're omnivorous also. These animals will eat carcasses or roots and vegetables and stuff like this. They're a pain in the neck where the open savanna meets the domesticated portion of life. And I would be more worried about rabies in those cases than I would be about, or an elephant coming into my property and eating all my crops, than I would be about transmitting trichinella from one place to another. But by the way, I know this hospital because we sent a medical student there a long time ago. And one of the cases that I described to you, I think I described this, one of the most unusual cases that I had heard of was a gentleman a native East African who had come in with a gangrenous nose. And it turned out that he was a cattle thief.
Mm-hmm.
And the owner of the cattle caught him stealing cattle,
Mm-hmm.
and he shot him with his bow and arrow. And the arrow stuck right in his nose.
I see.
And he pulled the arrow out of his nose, of course, but he had no way of healing his nose.
Yeah.
Until eventually it became gangrenous. Now, that wasn't the story, because this guy who was on his fourth-year rotation, he was doing a tropical medicine in the tropics under my tutelage. That is to say, I was in charge of the program, but I'm not a physician, of course, so I wasn't telling him what to do when he got there. But he went to this hospital. So they treated his nose, but at the same time, they noticed this large abdominal projection.
Mm-hmm.
Pardon me. And what they discovered was, of course, that he was suffering from Echinococcus granulosus as well. So they decided to operate. So in the time that this took place, guess what they were using for anesthesia? You'll guess.
Whiskey?
No, ether.
Ether. Yeah.
Ether.
It was popular.
The most explosive substance you can possibly use under those circumstances. Even a light bulb, right? Hanging over the operating theater.
Yeah.
And close by, if there's the slightest electrical spark of any kind, you could lose the whole operation.
Yeah.
And indeed, that's how they lit this place in those days, with just naked electric light bulbs hanging right down over the upper. So they put this guy to sleep. They operated on him. They took out the Echinococcus cyst, which was the size of a gigantic watermelon, and sewed him all back up again and repaired his nose and sent him on his way. It's amazing, just amazing stuff that went on in those days. And I presume this hospital is still. I would love to know from this inquirer, since I have helped you, I would like you to now help me. Tell me what the situation is like on the top of Mount Kilimanjaro with regards to the permanent ice fields that were written about so eloquently by Hemingway, called The Snows of Mount Kilimanjaro. Are there any ice fields left? Because that's one of the indicators that global climate change is occurring.
Well, my neighbor went to Kilimanjaro and did the hike last year.
Really?
He showed pictures.
Ice?
And there's no ice.
There's no.
He went to the very top and it's just stone.
Used to be glacier on the top.
I don't think so. Not
The
where he
mountain
went.
was covered with an enormous glacier.
But Rick should know. He's been there.
Absolutely right.
He says one more question.
Oh, okay.
In the excellent book, Manson's Tropical Diseases,
I own a copy.
the T. nativa Arctic cycle, T. nativa,
Nativa, yes.
trichinella,
Yes.
shows that polar bears can become infected by eating raw walrus and seal meat.
Correct.
How do seals and walrus become infected with trichinella? Don't they eat fish?
Not just fish. They eat anything that's available. Any meat source in the Arctic is eaten. And I can tell you that there's no such thing as a strict anything up there. If there's a carcass on the beach, I saw a wonderful nature show where a right whale had died and washed up on the beach. And there must have been 20 polar bears around this carcass. And they were feeding on it all winter. It was amazing. Just amazing. So to see the cycle, and the Arctic fox was feeding. Walruses will forage like this, and so will seals. So it's not unusual.
You said if you make a pig hungry, it'll eat a mouse, right?
A horse. Or a pig. Pigs will eat all kinds of things. They're omnivorous.
Will a horse eat meat?
Yes. Yes.
All right.
Cows will eat meat.
There you go.
That's how they get primed.
Well, they're fed it.
From?
It's rendered food from dead animals,
Yeah,
but
well-
normally a cow is going to eat grass out in the pasture. But if you feed it meat, it will eat meat, right?
What about wasting disease in civets? Cervids.
Cervids?
Yeah, cervids. Cervids.
Well, they could lick grass that's contaminated. Who knows?
They could grab a bite of grass and a vole would be in it. Who
Maybe.
cares?
Yeah, I suppose they wouldn't. They're not going to spit out the vole just to have the grass. Right?
No, that's just a little extra protein in your diet.
All right. Thanks, Rick.
Yeah, that was great.
Next one is from Ethan. Hello, Vincent and Dickson. I'd like to thank you for the superb podcasts I've had the pleasure of enjoying the past few months. Not having any previous interest in parasitism or virology, I downloaded a few podcasts on a whim and was immediately hooked. That's what we like to do, is hook 'em. Working a night shift by myself in the biology building of a university calls for TWiP's podcasts for entertainment. While listening to the TWiP episode on hookworm, I noticed a ton of slides left out in a lab room full of microscopes. What was on them? Parasites galore. I took the liberty of finding slides of hookworm in various stages of life cycles and got to follow along during the podcast.
Oh, nice.
And actually see with my own eyes real examples of what you guys were describing under the microscope. Cool. It was awesome.
That's great.
It was really good.
Wait a minute. Which university is that?
You didn't say.
Oh, too bad. I'd like to know who has those kind of slide collections anymore.
Yeah, that would be cool.
We certainly...
You threw yours out when you moved.
I didn't throw them out.
Where are they?
I have no idea.
If you had access to one, what would you do? Photograph all of them? Well, you have them all in the book already. You did it.
I have them all in the book. But I would take a slide collection set for myself. But I looked at that as improper behavior of a faculty member. I left them where they were, and it was up to the university as to what to do with them or not.
I really enjoy being able to learn from TWiP, being a non-scientist, although I'm going back to school for physics soon, so I'll be in the scientist club before too long. I have to look things up to follow along in TWiV, and TWIM is often way over my head, but I try to listen to both anyway. They're always interesting. I've since listened to all the TWiPs and would love to hear new ones added more often. I'm also looking forward to adding Dickson's new book, West Nile Story, right beside my recently read copy of Parasite Rex.
Wow.
Sorry for the lengthiness of this email, Ethan. No, it's not lengthy at all.
Yeah, you should read some of the ones from TWiV.
Really?
I mean, they're like experiments that they want you to comment on, and they've got all the procedures.
The next one is from Rebecca, our cytotechnologist, who wrote in after Trichomonas episode.
Good.
Thanks for mentioning my email and talking about my obscure profession. Cytotechs screen pap smears in addition to fine needle aspirations from just about any body site. A normal day consists mainly of screening pap smears, but I get to look at some lung, thyroid, liver cells, etc. Legally, we have to screen all paps at an appropriately licensed lab with a medical director and technical supervisor. Gone are the days of screening in your underwear at home. Well, maybe some folks can still screen in their underwear. My workplace frowns on it. A lot of slides are still hand-screened on a regular old light microscope, but some are analyzed by computer first. All slides must be screened by a cytotech or pathologist. The computer just uses a proprietary algorithm to determine the areas of the slide with the highest probability of abnormal cells to guide our screening. We send all slides we diagnose as abnormal to a pathologist. He or she has the final say. In addition to looking for cancerous or precancerous cells, we also look for non-cancerous infectious agents. HSV and CMV produce some gorgeous cells. Check Google Images for HSV or CMV cytology. As far as it being kind of boring to just look through the scope all day, you have to enjoy looking through the microscope, or you will quickly go insane in this line of work. I personally enjoy
even if you're not in your underwear.
That's right. I personally enjoy the focused attention this work requires. It's like meditation for me. Bonus, I get to listen to awesome podcasts while helping people.
Oh, great.
Additionally, the microscope rarely back sasses me, so I don't have to deal with any workplace conflict or stress.
Right.
Thanks again for the podcast. So we had asked her to tell us what she did. So there you go.
Rebecca just changed my whole image of a cytotechnologist.
I
envision them all sitting at home in their underwear. It's like Victoria's Secret, looking through the microscope. No, that's a bad thought. I guess we should probably not keep that. Or not. Could keep it.
Dickson, you don't have anything bad in you.
It depends on how you define bad.
Should we do one more?
Sure.
Next one is from Dan, who writes, "Hello, gentlemen. My name is Dan, and I'm considering becoming an epidemiologist. I discovered your podcast and am slowly working my way through all of the old episodes, which I find extremely fascinating. Forgive me if it's already been mentioned on your show, as I am listening to the episodes in chronological order and haven't yet arrived at the most recent one, but I would like to recommend a book called Parasites, Tales of Humanity's Most Unwelcome Guests by Rosemary Drisdell. I recently purchased this novel, and it served as a wonderful primer for your show and as fantastic thought food. If you can recommend any books, journals, or other publications that would be helpful for a budding young student such as myself, I'd be very appreciative. I know for certain that with my next paycheck, I'll be buying Mr. Despommier's Parasitic Diseases. Thank you very much for publishing this podcast. I'm happy that I discovered it. I think you had received this yourself from Dan and said that we're sorry that the book is out of print, but we're working on it, right, Dickson?
We are. We're producing an electronic version to put up on the Kindle and the Nook and the new iBook.
That will be done one of these days.
One of these days.
What else would you recommend that he read? What journal should he read about parasites? Well, he wants to be an epidemiologist.
An epidemiologist. Well, emerging infectious diseases would be a very good one.
It's free. It's online, open access.
Yeah, and that also has parasites in it, but it also has viruses and bacteria and lots of other things. So I would definitely pick that one. And maybe the American Journal of Tropical Medicine and Hygiene. There's lots of epidemiology in it.
All right, we have a lot more email, but we'll just have to do another show.
We will.
Because it is time to move on.
Indeed.
You can find TWiP at microbeworld.org/TWiP or at iTunes or the Zune Marketplace, of course. And if you are new and you like TWiP, go over to iTunes and just leave a little comment or rate it. You can rate it from 1 to 5 stars.
A
TWiP quip. And the reason we ask you to do this is the more comments and ratings you get on a podcast, the likelier it is to stay on the front page of the Apple iTunes directory.
Right.
And that way more people can discover us because we want to spread the word about parasitism.
Indeed.
And, of course, do send your questions and comments to twip@twiv.tv. Dickson Despommier can be found at trichinella.org, medicalecology.com, and verticalfarm.com. Thank you for joining us today, Dickson.
Oh, it's an extreme pleasure as usual.
Joining us, it's me and you.
Indeed.
Thank you for putting the time in, Dickson. I appreciate it.
It's a labor of love. Trust me.
I'm Vincent Racaniello, and you can find me at virology.ws. You have been listening to This Week in Parasitism. Thanks for joining us. We'll be back soon. Another TWiP
is parasitic.